Oops. All right, good morning for pre-calculus here. So we've got our test up, and I'll just say it this way. I tried really hard to get respondents to work for this thing, and we're not there yet. But we need a test. So as it is, I've put the test up. There's a pre-test. I urge you to take that first. Okay, so there is a pre-test up. I urge you to take that first. We're not going to worry so much about the, okay, so we talked a little bit about difference quotients yesterday, and we'll go on to polynomials today. All right, so things like how do I know it's a polynomial? If it has any of these corners to it or has any discontinuities, it is not considered a polynomial. Mostly I spent not a polynomial. Okay, not quite. Let's see if we can get up to a little bit more here. Okay, so yeah, let's just review something like this because this is a really representative type of a problem for me. So yeah, we've got 1/9. Here we go with the drawing. So we've got 1/9 x plus 5 x plus 2 x minus 4. Okay. So as we're speaking about this one, okay, if I were to multiply this out, don't multiply it out, but if you were going to, right, there would be 1, 2, 3 x's. There would be an x cubed somewhere in here. Okay, there'd be a 1/9, but notice all of these are positive. Okay, it's just a +1. If it wasn't the case, right, what if we had something like this? We had x plus 5, x plus 2, and instead of x minus 4, what if we have 4 minus x? Well, here the coefficient at the beginning is negative, so we'd end up with a negative x cubed at the front. All right. I mean, there'd still be that 1/9 out there, but that would turn into a negative here. Okay. So because these are all just 1, we're going to end up with an x cubed. We're going to end up with a positive x cubed. Okay. So we know it's degree 3, and we know that the leading coefficient is positive. Okay. So just without doing anything else, okay, I kind of know that my end behavior is going to look something like that. Okay. Now it's going to wiggle around in here a little bit, but in the end, this is what it's going to look like, because that's what all odd polynomials look like. Here, odd degree polynomials. Okay. So now we have to set this thing equal to 0 and solve, right? We're going to use zero factor principle, so it's 1/9. X plus 5, x plus 2, x minus 4 equals 0. That means either x plus 5 equals 0, x plus 2 equals 0, right? Or x minus 4 equals 0. We could do that because if you know, right, if 3 things multiplied together equal 0, well, either this one's got to be 0, that one's got to be 0, or that one's got to be 0. Or maybe all 3. But one of these at least has to be 0. So we got x equals -5, x equals -2, x equals +4. Okay. So again, well, all right. 1, 2, 3, 4, 5. X equals -5. X equals -2. And x equals 1, 2, 3, 4. Okay. Now, do you remember talking about the powers of each of these factors? And if these were odd powers, then the graph went through the 0. But if this was an even number, then it bounced, right? It bounced on that. So in this case, right, because these are all positives here, right, we can go ahead and do that. It's going to go through because it's only a 1, right? And if this is going to go through because this is only a 1, and then we can do this. There is a slightly more, there's a slightly better way to do this if you weren't sure, okay? How could you test this? Well, what if I picked your favorite number between -2 and -5. Pick any of them, okay? Pick your favorite number somewhere between -2 and -5. Let's pick -3. If I plug -3 in here, right, with $3 in debt, you pay back 5 of them. You're in the positive. Okay, you're no longer in debt. If you're $3 in debt and you pay back 2, well, then you're still in debt. I'm sorry. If you're $3 in debt here and you spend $4 more, well, then you're still in debt. Now, what we're going to do with these, numbers, right? We're going to go ahead and multiply these together. Okay. So if I multiply two negatives together, we get a positive, and I multiply that positive and still get a positive. So when x is -3, I know the graph, I know the whole function is above the x-axis because we end up with a positive. Okay. What if we wanted to double check between, say, -2 and +4, right? Pick your favorite number between 4 and -2. Anytime you go from a negative to a positive, your favorite number is 0. Okay, it's that's just a rule. So we're going to go ahead and pick 0 here. 0 plus 5, 0 plus 2, 0 minus 4, negative. When I multiply these all together, positive times positive is positive, times negative, we get negative. Hey, what do you know? It's actually a negative down here. You don't have to test all of these points. Usually if you test one and remember, you know, what's going on here, you've double checked yourself enough to make sure that you're doing it right. Okay. But there's nothing that says we can't double check all of them. Okay, we won't because we have more to do, but you could. Okay, maybe check one just to make sure that you know you're up here somewhere and you didn't mess up the end behavior somehow, right? But it's a way to double check yourself. Like, does this look the way I think it ought to look? Okay, so yeah. So the end behavior of the function, right, is the end behavior of the function is something to the left. It's down to the left, right? It's down here. It's down to the left. And up to the right. Okay, so be careful. Is that all they wanted to? That's not all they wanted to ask. We have 4 parts here. That's kind of nice that they let us do it piece by piece, though. Okay, find the y-intercept if there's more than one answer separated by comma. Okay, so intercepts are, right? Intercepts are the variables take turns being 0. Okay, you set one variable to 0. So we're going to set a variable to equal to 0. Now, is it a y-intercept or an x-intercept? Which one do we go with? Well, you've been doing this your whole life, right? And we call this slope-intercept form. We know this one is the y-intercept, right? So y equals mx plus b. This is my y-intercept. Okay, so when x is equal to 0, we get our y-intercept. Does that make, oh, I can't ask you. I hope that makes sense. All right. And I'm just trying to link this back to stuff that you already know because I know a lot of people, me included, you know, it's like y-intercept. Like, which one is that? It's where it hits the y-axis. You go back to this. So we're going to set x is equal to 0 here. Okay, which means I could have put numbers in here. That would have been fine. But we're going to have a 1/9. Right. So we have, what do we have here? We have 1/9. We have x minus 5. No, we have x plus 5. X plus 2, x minus 4, right? And if I plug 0 in, right, we have 5, 2, and -4. Okay, so we have to multiply this all out. What is this going to be here? This is going to be 10. It's going to be 40. So it's going to be -40 over 9. Okay, so my y-intercept, 0, -40 over 9. Okay, so we have 0 and -40 over 9. Okay, check your answer. All right. Find the real zeros of the function. Hey, we've already done that too. Okay, we've already sorted out what the zeros are. We know that it's -5, -2, and 4. Again, I'll pause this for, I know we're reviewing, but I'll pause this for a moment. There's a theorem that says, you know, for whatever degree this is, you could have up to that many zeros. Now, some of them are complex zeros, and some of them are real zeros. So if I did an x squared plus 1, set it equal to 0, we're never going to do this in our class, but right, plus or minus I. This would not be a real 0. We're not graphing it right on our x and y plane, but they are an imaginary 0. So this has two imaginary zeros. We have a polynomial of 2. So that's the reason why they ask it that way. All right. So let's see here. It's -5, -2, and 4. So this case, they want -5, -2, and 4. Okay. And those are my zeros. Okay. This is also why it's important to do the pretest, because it's important to remember, like, did they want a point? Did they want just values? In this one, they just wanted values. Here, they wanted a point. All right. And we're going to graph it. We kind of already did, but, you know, there we go. Plot at least 4 points. Hey, what do you know? You have 1, 2, 3, 4 points. So let's go ahead and give us a 0. And this is -40/9. Plot that point. We're going to kill that off. And then with our pencil here, we could do a -5, a -2, and a 4. And then we'll go ahead and do that. And that looks pretty good. Okay. So don't do more work. Don't think, well, I've got to use 4 new points. Like, no, they've already made you figure out 4 points. That's why they chose 4. So you don't have to keep going with that. Okay. All right. So that's how that works. Okay. I don't think we did one like this when we were working it through the last time. So maybe we try one like this. Okay. So if we were still face to face, we'd be doing a lot of factoring. Okay. So we have t of x, right, is equal to x to the 4th minus 3x cubed minus 10x squared. Okay. So our leading, right, our highest degree is a 4 here. Okay. So I know that since this is a 1, this is positive. So an, right, leading coefficient is positive. The degree is even. We're going to end up with an behavior that's going to look like that. Okay, just like a parabola. Okay, so our end behavior is up, whether it goes to the left or right, both up. Okay, so the other thing is we're going to have to figure out zeros eventually. So what we're going to have to do here is we're going to factor. So this is x squared, x. All right, and if we take an x squared out, we have an x squared minus 3x minus 10. And I'm wondering, like, can I factor this thing, right? Well, how about x minus 5 and x plus 2? Right, that's minus 5 plus 2 x's. That's going to give me my minus 3. When I multiply these together, we get minus 10. Okay, so we have some zeros. Okay, we have, you know, where is this equal to 0? We have x squared equals 0. That's x equals 0. We have x minus 5 equals 0. That's x equals 5. We have x plus 2 equals 0. That's x equals -2. Okay. This one has a double. So, you know, this is going to bounce when it gets to this one. When the graph gets to here, it's going to bounce. But these two are both singles. So it's going to go through the axis. Okay. So let's go ahead and we'll start just asking what's going on here. Okay. The function goes up on the left and up on the right, but up in both directions. Okay. Find the y-intercept. Well, again, that's going to be where x equals 0. You can choose any configuration you want. Okay, in this case, because every term has an x in it, okay, x, 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 if I set x equal to 0, that's a real easy problem. So we're just going to go ahead and say that's the origin, that's 0, 0. All right. Okay, find the real zeros of the function. Okay, we already did. There's 0, 5, and -2. 0, 5, -2. I wonder if it'll yell at me for putting them in a bad order. No, it didn't care. All right. And then we're going to plot this thing. Okay, if I was going to plot this by hand, right, we'd have 1, 2, 3, 4, 5. We'd have 1, 2. We'd have 0, 0. Knowing that my end behavior is going to look like this. Okay, so we're going to come down. When we are at -2, right, this is a single powered root. It's just got a 1 here. It's an odd power root, I should say. So we go break through. We hit the origin, and what happens at the origin? We bounce. Okay, and then when we hit 5, we can go through because that's our deal here. All right, and that would be how the graph of our function here. Okay, so we have to plot at least 5 points. It looks like we only have 1, 2, 3, 4 points here. We need one more point. Okay, so let's see here. What do I have for points? I have 0, 5, and -2. Really? You're not going to give me a pencil? Thanks. 0, 0, plot point. Was it -5 or +5 here? 5. Okay, so we have 5, 0, and -2, 0. All right, and we have 3 points here. It's delightful. We need 2 more points. Any 2 points will be just fine. Okay, so pick your favorite numbers somewhere on the real line. I suggest 1. I kind of like -1 as well. Okay, so what are we doing? We're multiplying all these together. Again, you want to put it back and do this, that's fine. Okay, but what we have here, right? We have x squared, we have x minus 5, and x plus 2. Why don't we try x equals 1? So we have 1 squared, 1 minus 5, 1 plus 2. All right, so that's going to be 1 minus 5, that's -4. We're multiplying all these together times 3. That looks like -12. Okay, that looks like -12 here. So we have 1, -12. And they didn't tell me that I had to do it like in different intervals or around different zeros. We could pick 2. It's okay. We could pick -1. Okay, let's let x equal -1. So we have -1 squared, -1 minus 5, -1 plus 2. 1 squared is 1. Right? You're $1 in debt and you spend $5 more. Now you're $6 in debt. Congratulations. You're $1 in debt and you pay back 2. Right? Now you're 1 on the other side. So this is going to be -6. Okay, so when x equals -1, y is -6. So we have -1 and -6. Plot the point. All right. And then we're going to hit this button. And there we go. Let's see what we have. Yep, that is, yes. Actually, I'll show you something else in just a second here. But yeah, whatever format is the most convenient, that's the one you should use. Okay, that's definitely the way to go. And it is your choice. All right, so let's go ahead and look at this. Just as an aside to kind of go off of that. Like, I know we have calculators now, and doing this is not that big of a deal. But since these are the differences of 2 squares, you could break this apart and say this is 101 minus 99 and 101 plus 99 and multiply it out that way and get 2 and then 200 and get 400 and not have to worry about doing a lot of arithmetic. Okay, But yeah, age of calculators, these kinds of tricks are not as useful. Let's see, oh, this one looks terrible. Oh, this one doesn't look too bad. But we should do this one. This is a scary looking one, so we'll try this. Okay. Sorry about my heater. All right. So the easy parts, right, is we have a 5th degree polynomial. And the first number, right, our leading coefficient is positive. So at least we know what this looks like. Getting the zeros is going to be a little difficult, but we have some information already. Right? If I was going to ask to draw this thing, I know my end behavior, something like that. This is my end behavior. Okay. What if we have to go through and figure out how to graph this thing? We're going to need zeros. So what we're going to do here is we're going to do something called factoring by grouping. Okay. Actually, before we do that, I could pull x squared out of all of these things, couldn't I? So maybe doing that first. So all of these are going to go down by 2. So this is going to be 4x cubed plus 8x squared minus 49x and then minus 98. There's the x squared right there for it, right? So that's the first grouping, first factor we're going to do. Then we're going to go ahead and group these together like this, all right, and do factor by grouping. Now, as I'm saying this, realize that sometimes you might decide that the first and the third one are a better group together. A lot of times they are. But in most of the books I've seen, like for the past maybe 10 years, they usually just do 1, 2 grouped and 3, 4 grouped. Okay, they used to do like 1, 3, and 2 and 4 we group together better. So they still could, but you're probably going to get it as a 1, 2, and then 3, 4 to group. Okay, so not a squared, just a squared. Okay, what can I pull out of this guy that's common, right? We've got an x squared that's common, we've got a 4. So we're going to pull 4x squared here. And what do we have left? Well, we have an x and then a plus 2. Okay. And then minus, well, both of these are minus, so I'm going to definitely pull out that negative sign there. And it looks like I can pull out a 49, right? Because 49 times 2 would be 98. Okay. So we can pull out a 49. And then what do I have left? We have an x, and the negative went over here, so it's now positive. This is the tricky one. This negative is over here, so it's still there. All right? Okay, not done yet. Notice, right, that we have a an x plus 2 common to both terms. We could pull that forward. Okay, we could pull that. We could factor that out as well. So we can have an x squared. I'm going to put the x plus 2 here. And then what do we have left? 4x squared minus 49. If I were to distribute this back, we would get the same thing. You should always check. If I put this back in, do I end up here again? Yes. Okay. But don't answer yet, because that's the difference of 2 squares. So we can even keep this going further, x plus 2, and then we have 2x minus 7 and 2x plus 7, and that's finally all of our pieces, okay? So again, if I were to set this equal to 0 and solve, because I wanted to know what the zeros were, we'd have x squared equals 0, we'd have x plus 2 equals 0, we have a 2x minus 7 equals 0, and a 2x plus 7 equals 0. All right. So there we go. We have x equals 0, x equals negative 2, x equals 7 halves, and x equals negative 7 halves. Okay, that's delightful. Okay, that's right. If you want to punch in your calculator and get what 7 halves is offhand, right? It's 3.5-ish. Okay, it's 2.5 exactly, actually. So just to have an idea, like where is it on the number line? Okay. So great. Let's go ahead. Oh, they just want to sketch the function. Oh, the end behavior. Okay. So it's going to be down to the left and up to the right because it's an odd polynomial with the first coefficient positive. Y-intercepts. Again, we got to plug in x equals 0. This is not a tough problem to deal with, right? We let x equal 0, everything is gone. So this is 0, 0. Okay, I know everything is clicking on me. You're only, I know they say if there's more than one. Anytime there would be more than one, you don't have a function anymore because it fails the vertical line test. So chances, when you see this more than one business here, they're bluffing. Okay, with a polynomial, they are bluffing. Find the real zeros, and we did that. We made sure we got all the real zeros here. And again, they just want a list. They don't want us to. They don't want us to get points. They just want a list. So 0. We have -2/7. We have a +2/7. Let's see here. We have a -2. Okay, and those are our choices. Oh, check answer. Okay. Try again. What did I not do? Oh, 7/2. Not. Okay. 7/2, not 2/7. All right, there we go. And make that a comma. All right, that looks a little better. All right. Okay, I don't know what they do for tests. I left almost everything like it should be for homework, except I only put in one try. So I hope they give you, like, when you make that mistake, because everybody makes that mistake. I hope they warn you so you don't have to do that. And again, they didn't give us a pencil. Thanks. 0, 0. Plot. Okay, what else do we have? We have -7/2. Zero. We have 7/2. 0. We have -2, 0. All right, how many points do they? 6. Good Lord. Well, there's 1, 2, 3, 4 of them. Again, pick your favorite two numbers somewhere on this axis, and let's. Yeah, let's pick one and -1. Okay, let's pick one and -1. So we have x squared, we have x plus 2, we have 2x minus 7, 2x plus 7. So when x is equal to 1, just want to make sure I got the right thing here. Yeah, I think we're okay. So when x equals 1, we've got 1. 1 plus 2 is 3. 2 times 1 is 2. 2 minus 7 is -5. And we have 2 plus 7, which is 9. We just got to multiply all of this out. Okay. What is 45 times 3? I think that's 135 negative. Right, or 15 times 9. Oof, that's 90 plus 45. Yeah, it's 135. All right. So that's one of them. Okay, actually, let's go ahead and put this here. All right, let's go ahead and put this here. X equals 1. How about when x equals -1? Well, put a -1, we get -1 squared, which is 1. -1 plus 2, which is 1. And if I put -1 in here, right, we have 2 times -1 minus 7. So that's going to be -2 minus 7, that's -9. And then putting in -1 here, that's 2 times -1 plus 7. So that's just going to give me -2 plus 7 would be 5. All right, so that's 1, 1, Okay, that's not so bad, right? Let's make sure I get all my signs correctly. Multiply all this mess together, negative 45. Okay, so when x is negative 1, y is 45. When x is positive 1, negative 135. Oops. Where are we going here? So we've got 1, oops. What's going on here? 1. Thought that would have done it for me. That was what, negative 135? Well, the scales on this. All right. Oops, I didn't like that at all. Gave me the wrong one. Huh. It did not like that point. Let's double check the arithmetic here. See, this is the other nice thing is that, what did I do? You know, it does. It really does. It's a lot better than it used to be, but I appreciate the fact that yeah, it's still fun. So here's our original problem, right? Is 4x to the 5th plus 8x to the 4th minus 49x cubed minus 98x squared. Okay. So let's go ahead. So that's the other nice thing is if you have two different representations, we can go ahead and work this two different ways. So let's go ahead and check this out. We've got 4 times 1 plus 8 times 1 minus 49 minus 98. Okay, so we have 4 plus 8. 4 plus 8 minus 49 minus 98. Well, that is 135. Oh, wait, was that positive or negative? It's negative. What did I type in? Huh. I don't know what it's like. 1, 2, 3, 4, 5. Oh, let's do this. Let's erase that point. Okay, let's see if that is better. All right, I have a feeling that I probably hit return by accident too early, and that's probably where that came from. Okay. Oh, it should be negative. Thank you. Let's erase that one. Good catch. Thank you. 1 and negative 135. Yeah, like I said, same thing. I have a feeling I put something in there and accidentally hit return, and that's what it didn't like. So let's go and hit my other one, right? That was negative 1 and negative 45. All right, plot that point. And now, yeah, okay, the level 5 or 5th degree polynomial, we still end up with that same behavior. We have a bounce, right? We see a bounce here, and everything else looks like it's good. So it goes through, bounces, goes through. Oops, don't plot the point. Get rid of you. And we check answer. All right, there we go. Okay. So I don't know if they do that or not. We'll see. Okay. So let's see here. All right. Actually, let's push on to next section, because these are going to be like more the same every single time. Yeah. So let's go ahead and push on to the next section, because the rationals ones, those are always, they take a long time to deal with, and they're a little bit more involved. So let's have a look at that. Again, we say week 3. Oops, not week 3 with inverses. We see week 3 here, and we have our rationals. Okay, start assignment now. Very good. All right. So we'll go ahead and hit that. Let's start with, see if they can give us one to graph first, and then we'll go through and do this. I know I put at least one of those on there, but I want to just go through a regular one first. Okay, so we're going to deal with the graph for 4x plus 7 over x squared minus 9. Okay, so check common factors. Right? Since the bottom factors, it's one of those things you should kind of have something in your head about. It's x minus 3, x plus 3. Okay. If you didn't check common factors, I can just tell I would believe you, because there's no way you're pulling it with 4x plus 7 out of this. Okay. One is we have our vertical asymptote. Okay. And that is where the bottom is equal to 0. So we're going to set x minus 3, x plus 3 equal to 0. So we're going to have an x minus 3 equals 0, x plus 3 equals 0, x is equal to 3, x is equal to negative 3. So the lines, x equals 3, x equals negative 3, those are our vertical asymptotes. Okay. How about the horizontal asymptote? All right. 4x plus 7 over x minus 3, x plus 3. Okay. So remember, there's 4 different little rules for 4 different cases for a horizontal asymptote. And this is the first case, because the degree of the top, right? The degree of the top, that was 1. We only had a 1 here. But if I multiply these together on the bottom, we'd have a degree on the bottom, right, is equal to 2. So the top is a smaller degree than the bottom. That means we have a horizontal asymptote at the line, y equals 0. Okay. What else are they asking for? Identify the y-intercept. Again, if you have trouble remembering it, right? How do we get the y-intercept here? It was mx, right? Set x equal to 0, y is b. So if we go back here, right, and set x equal to 0, we've got 4 times 0 plus 7 over 0 squared minus 9. That's 0. And all we have here is negative 7/9. Okay. And again, it doesn't matter. You want to write that, you want to write this, you want to write this. They are all the same number. So that's okay. So that's my y-intercept. Okay, so 0, negative 7/9. Okay. And then they're going to ask us, what else are they going to ask us here? They're going to ask rate numbers as integers or simplified fractions. I have a feeling they're going to ask us for more points, but we have, oh, x-intercepts. Okay, that's, all right. So y-intercepts was when x was equal to 0. X-intercept, it's y's turn to be 0. So we're going to have our 4x plus 7 divided by x squared minus 9 set equal to 0, because that's y. Now we've got to solve this rational equation. The first thing we're going to do with this is we're going to multiply by x squared minus 9 on both sides. And that's going to cancel. And we're just going to get a 4x plus 7 is equal to 0. So x is going to be negative 7 over 4. Okay, and that's our only y asymptote. It's only one we have to, or only x asymptote really, not asymptote. Intercept. All right, so we have negative 7/4 and 0. Okay, our equation of our vertical asymptotes, we had two of them, right? We had x, where's my equal sign? Equals 3, but we also had, right, where's my comma? Comma, x equals negative 3. Okay, so we have two of them. Okay, equations of our horizontal asymptote, we did not have a slant asymptote. You have one or the other, we never have, but this is a bluff. Okay, but we had y equals 0 because of the degrees. Okay, but again, you have a horizontal or you have a slant. You do not have both. Okay, y-intercepts, that was write your answer as an ordered pair. Thank you very much. So that was a 0, and they said y-intercept, and that's negative 7/9. All right. Please fill in the empty boxes. What empty box? Oh, none. Thanks. All right. They didn't make us graph it. All right. They actually generally don't make you graph it if you have multiple of these things anymore. Okay. But all right. Now we get to construct one. Okay, now we get to go backwards. We get to do everything we just did, but in reverse. So we have our horizontal asymptote of y equals 3. Okay, so they're given y equals 3, the line. Y equals 3. Well, again, there's 4 conditions, right? There's 4 cases. The first one was y equals 0, so it's not that case. The third one is we had an oblique asymptote, right? We had a y equals mx plus b here, because this was when it was 1 bigger. So it ain't that one either. The fourth one was there's no asymptote. So it's got to be 2. And this was when the degree of the top was equal to the degree of the bottom. So whatever I'm going to have here as a y equals, we're going to have some kind of an, well, it's the ratio. So we're going to have some kind of a 3x to the n over 1x to the n. Okay, plus some stuff, plus some other stuff. I don't know what these degrees are yet. They might be a speed 1, but whatever they are, right, they have to be the same. So if they're squared, they both have to be squared. If there's 1, they both have to be 1. And we know it's 3 because 3 over 1 is how we're getting our asymptote. Technically, it could be like 6 over 2, but generally we're gonna try to keep it as simple as possible. Okay, how many vertical asymptotes do we have? We have 1. We have x equals 1. So whatever's going on here, right? We got that because we set the bottom equal to 0, and that's what we ended up with. So we're going to pull this to the other side. We'll say, oh, that's x minus 1 equals 0. So the bottom is x minus 1. So we have a 3x on the top, x minus 1 on the bottom. We don't know. There might be other stuff in here. Okay, we'll find out. All right. So y-intercept, 0, 4. Okay, so 0, 4. That was, right, to get a y-intercept, we set x equal to 0, right? And then y is equal to 4. So if I've got 3x plus some stuff divided by x minus 1, well, when I set x equal to 0, right, we've got some stuff over minus 1, and that's got to equal 4. Does it make sense that this stuff has to be a negative 4 in order to make this positive? Okay, so our y-intercept is, or because of our y-intercept, we're going to say this is 3x minus 4, x minus 1. Now, if I plug in zeros, we get 4. okay, and everything else is good. And then X-intercept, right, is when y was equal to 0, and we solved. And in this case, we ended up with, right, 3x minus 4 equals 0. Hey, this looks pretty good. X equals 4/3. Looks like we're set. Okay. Looks like we're set for this. Okay, so graphing this thing. Sketch y equals 3. Okay. By the way, I've been told, I know that you know, sometimes when people did this, the computer said yes, close enough, that's fine. And other times it said no, you're wrong. You know, we only gave you like halves as a chance to do this, but we're going to mark you wrong anyway because it should have been like a sixth, and you didn't rate a sixth, you rate a half. So when that happens, it's for some people it will. I'm gonna have to go through the test for you guys and fix that. So if it did happen to you and you want to shoot me an email to make sure I see it, then please do that. But I will also go through it on my own as well, just to double check. Okay, because I know that it does that weird stuff. Okay, sketch the asymptote. That's all I wanted, was to do the asymptotes. Okay. Graph this point. Okay. So really? Okay, well, 0, 4, I think we could do. 0, 1, 2, 3, 4. Okay. But this one, I'm not gonna be able to do 4/3. 0. Oh. Thirds. 0. Plot it. All right. That's all they wanted. Looks like that's all they wanted. All right. Oh, then we have to choose which one we like. Okay, well, we're going to have one of the graphs is going to be second quadrant, right? We need an arm in the second quadrant and the fourth quadrant. So second quadrant and fourth quadrant. I think we're here because the horizontal asymptote everywhere else was terrible. So I think we're down here. Try again. Oh, how about you pick the right one? Okay. So again, go through the pretest and try to avoid mistakes like that one because that's going to happen. All right, that's probably enough for today. I'll keep going over the rational ones tomorrow, and then we will do inverse on the day after that. Okay, and I will send out an announcement explaining what the parameters of the test are. Okay, so I'm going to stop recording there.